Section 6.3 is where we are going to introduce finding nth roots and use rational exponents, which other words means fraction exponents. You've been used to doing the square root, which means this index has always been a 2. It's never been written there. So with this radical, you will have a number here that can be various roots. For example, a cube root, a fourth root, a fifth root, a sixth root. So this can be any number. So far, you've been doing square roots they don't put that 2 right there. So there's different kinds of square roots that you can find. Whenever they're giving you these symbols, they can use just the positive square root, the negative square root, or this is suggesting that they want both of them, the positive and the negative. So we're going to practice finding those roots. And so here's my first example where it's asking simplify the positive and negative square root of 25x to the fourth. So first thing, recognizing they want both kinds of roots. So they want the positive and the negative. Then they're going to ask you to do the square root of 25. And they're going to ask you to simplify the square root of x to the fourth. So the first thing I did was I just rewrote it so that you could see that we were splitting it apart. So anytime that you have a multiplication, that's going to separate all of those numbers or variables apart. Now I'm just going to simplify. So if you don't know the square root of 25, you can type it into your calculator. So remember that your square root is above your x squared right here. So I can hit second x squared, and then my square root will come up, and then I can type in 25, and I get 5. I can also simplify that x to the fourth, recognizing that that square root means that you are really raising it to a power of 1/2. So anytime you see this square root symbol, it's technically 1 over whatever that index is. Okay, so there's two ways to think about simplifying this. If you have x to the fourth, you can rewrite it out so that you have 4 x's. And when you had that square root, we were always finding pairs. So we would be finding square roots. I'm going to find 2 pairs, so I would be left with x to the second on the outside. The other way to think about it is this fraction exponent. This square root means I have it raised to the 1/2. So if I distribute and I do 1/2 of 4, we would find that it's also x squared. You can think about it however you would like. I will typically just keep using this fraction exponent. Let's take a look at letter B. So on letter B, it wants the negative square root of this expression. So I'm going to be doing the negative square root. And remember, we just got done discussing that square root means I'm doing a fraction exponent. So I'm going to be doing 1 over whatever my index is. And since the index is not written, I automatically know it's a 2. So now I'm just using my exponent rules to distribute this guy. And so I'm going to have the negative still here, my expression here, and then I'm going to distribute these two so that I get 6. Okay, let's take a look at another one over here. So I have now a cube root because my index has changed to a 3. So whenever it has a number there, that's automatically what your index is going to be. If there's not a number, we assume it's a 2. So the first thing I did was I rewrote it so that each part was separate. So I'm doing the cube root of 343, the cube root of a to the 18th, and the cube root of b to the 6th. So first off, we already talked about how to type in a square root. So you're going to want to type in a cube root, and to do that, you're going to want to go to these keystrokes. So you're going to hit math on that first column, and then when you hit math, you have all these options. The fourth one is your cube root, and your fifth one is any nth root. So if you want to type in a cube root, you can just hit number 4. If you want to use number 5, you have to put in the index beforehand. So for example, if you just do number 5, this isn't going to work because it needs the number of the index in front of it. So if you were doing the 4th root, you'd have to hit a 4 and then type in that number 5 option. So that's telling it to do the 4th root. Okay, but if you're doing the cube root, it's already set up for you. So you can just hit number 4, and then our number was 343 that we had there, and then just hit enter, and your answer would be 7. Then over here on the next one, these are fraction exponents. So a cube root means that I can rewrite it as a fraction exponent of 1/3. And if I have same over here with my b, this cube root can be rewritten as a 1/3. Now all I have to do is distribute those exponents. So multiply these guys together. So 1/3 of 18 is 6, and 1/3 of 6 is 2. Okay, let's try one more together before I let you try some on your own. So this is just wanting the positive square root. A little different. You're still going to split it apart like we have before, but you want to consider the fact that you can't type in the square root of a negative. So we're going to take out that -1, and so that we're left with 289. Once you've done that, remember your square root of -1 is equal to I, and then you can see if you can type in the square root of 289. So second x squared, and then 289. It is a nice perfect square root, so I can type that in as 17. And so then I would have 17i from that square root of -289. We already discussed this. Square root means you're just doing half. So I'm doing half of 8, half of that 4. So that's where you're getting c to the 4th and d to the 2nd. Okay, I'm going to have you pause the video, and you're going to try all 4, if I can get them all on the same screen. Try all 4 of these down here at the bottom and try to simplify those. Okay, so on letter A, you should have gotten the positive and negative 6, and then half of this 8 would be x to the 4th. The next one is just a negative square root, so I'm doing the negative of that expression, and then square root means I'm doing half of this, so that would be 8. The next one, you're doing a cube root, so you are finding the cube root of 64, which is 4. Now I'm doing a third of these exponents, so I would have a to the 8th and just b to the 1st, or just b. On the last one, you had the square root of -441, so you would have to take out that -1 first, and then you're left with 441. That square root of -1 is where you're going to get that I, and then you can type in the square root of 441. So I would get 21i from this guy here. Square root means I'm doing half of my exponents. So half of 12 is 6, half of 16 is 8. Okay. Some other things to think about is whenever you have exponents in here, we're going to rewrite from exponential form to radical form and then flip-flop it as well. So the index will always be on the bottom, so that's going to tell you what nth root you have. The exponent will always be going on the outside, so it'll be the top part of your fraction. You are considered to be simplified with all of these exponent rules when you don't have any negatives in there. When you don't have any negatives in the denominator, you can't have a fraction within a fraction, so something like that. And then the index of any remaining radical is the least number possible. So like if you had a square root over a 4th root, you can simplify those to condense them down. Okay? So we're going to look at just a couple more, and then that'll conclude day 1. So what we're going to do is we're going to practice rewriting from rational radical exponents to exponential form. So if I have x to the fourth, I would rewrite that so that this bottom number is my index. So I would automatically do the cube root of x, and then this top number will always be your exponent. So you'll write x to the fourth cube root. Going in the reverse, if I had the fifth root of x to the second, I would just make sure that this would go on the bottom as a fraction exponent and this stays on top. So it just becomes x to the 2/5. Now over here, a little bit more progressing. So you've got multiple things that you are doing. First, I'm going to rewrite this so that I have a fraction exponent. So everything gets raised to the 1/3. Now I'm going to use my exponent rules and I'm going to make sure I distribute that 1/3 to every variable or real number. So I'm going to write it as 2 to the 1/3. This would become x to the 2/3 when you distribute, and then y to the 1/3. Okay, let's take a look at one more. So you have fourth root of 16x to the fourth. Rewrite that as your fractional exponent. So I'm going to rewrite it as 16x to the fourth, all raised to the 1/4. And then everybody gets that fourth power. So I'm doing the fourth root of 16. And then I'm also doing x to the fourth raised to the 1/4. So that would just be 1. And then technically you could take this one step farther. If you're doing 16, fourth root of 16, that would just give you a 2. And then you still have your x to the first. Okay, let's have you pause the video and see if you can do these guys. So you're just switching their order, going in the opposite direction of how it's written. So this one is in rational exponent, so write it in radical. This has a radical, so write it with an exponent. So on that first one, you should have kept it x to the third and then just made it become 7th root. On letter C, it would become x to the 4/9. So those should be pretty simple, just keeping that same exponent and then writing that index on the bottom or vice versa. Over here where you have more of them, you're going to do the cube root of 8, which is 2. And then I'm going to do a third of 6 like we did before, and a third of 2, which is going to just be 2/3. So distributing that 1/3 to everybody and simplifying. Fourth root means I'm going to rewrite it as a power of 1/4, and then everybody gets it. So 3 to the 1/4 and x to the 3/4. Okay, so that's going to conclude day 1 of just practicing those exponent rules. Day 2 is where we're going to still continue practicing that, dealing with some word problems and some other types of simplifying expressions. So financial literacy, for example 4, here's an expression that can be used to estimate the future cost of an item due to inflation, where C represents the current cost of the item, R represents the annual rate of inflation, and T represents the time in years. Write the expression in radical form for the future cost of item 3 months from now if the annual rate inflation is 4.7%. So I'm going to see if I can find things that I can put in my formula. So I see an inflation of 4.7%. I see the future cost after 3 months. And then I don't really see a whole lot anymore. So I see up here it tells me that R is going to represent my inflation rate and T is representing my time in terms of years. So that's going to be important. C is my current cost, but I don't see where they are giving me that. So I rewrote this as C staying as it is. 1 plus your percent always has to change to its decimal form. So you always will take that and move it over 2 spots to the left and fill in any blanks with 0. So 0.047 is the decimal form of that percent. And then this 3 months is going to be my T, but it did say in terms of years. So years means I have 12 months. And so I just reduced that fraction to 1/4. Then they wanted me to write this expression in radical form. So I don't see any fraction exponent on the C, so it's going to stay as it is. And then this whole guy with the 1/4 is the one that's going to have the radical above it. So I'm going to write it like this, where I put the 4 as the index with my radical above it. And then if you can either write it like this or just simplify it to that 1 decimal. So first step, pulling out important information and putting it in the correct steps. And then the second stop, you want to simplify that so it goes into radical form. Okay, let's just take a look at a couple more here. So what if they give me something like this, where I am asked to find 64 raised to the negative 1/6. Anytime they ask you to evaluate those guys and everybody's a number, just type it in your calculator. So 64 and then I'm going to raise it to an exponent, so that means you're using your exponent key right above the division sign. And then remember, with fraction exponents, you have to do parentheses. I'm doing -1 divided by 6, so that's how we finish our parenthesis, and then hit enter. So then my answer is 0.5. On the next one, we have 8 raised to the 4/3, so type it in, 8, exponent button, raised to the 4/3. So notice again, I put that fraction in parentheses. My answer is 16. Pause the video and see if you can do the last question. So after typing in 32 raised to the negative 2/5, you should have gotten 0.25. So it should have looked like this, 32 raised to the negative 2/5, and that's how I got my 0.25. So if there's no variables inside of there, just use your calculator and type it in. That's the easiest way to go about it. All right, last part here, just making sure we reiterate our exponent rules. We already practiced these exponent rules, but just making sure we're good. So remember that when you are timesing, you are actually adding those exponents. So just use your calculator and type it in. So I've got 3/5 plus 7/5. And remember how I type in fractions and I hit enter. So I got x to the second. And then over here, we've got a power to a power. So that means we are going to distribute those exponents. So I'm doing 1/3 times 2/3, and I get that big long decimal. Remember, you have the power to change it to a fraction. So hit math. And then the top one will change it to a fraction, the second will change it to a decimal. So we want to change it to a fraction, hit enter. So I would get 2/9. So x to the 2/9. All right, so this lesson is all about making sure you understand your exponent rules along with those fraction exponents, which we will refer to as rational exponents.